Who of you has had an X-ray? An MRI? PET scan? CT? Do any of you remember what it was like? Sure, go ahead. Yeah. And isn't it funny how you go from lying on that table, having something pounding, taking pictures of you, to an image of the inside of your body and a diagnosis? Well, that's the majesty of biomedical imaging. Clicks. I'm Megan Ranelli, and this year I study biomedical imaging under the mentorship of Andre Martins. Now, I didn't start out in this field exactly. In fact, I began wanting to study radiology. That's the doctor that sees these images and tells you exactly what's wrong. And a few weeks into the year, I decided I wanted to do neuroradiology. I thought I found the path, but when I started doing research, I realized that what I was really interested in was the technology. How you go from one thing to another. What exactly makes these images possible? Now, I focused mostly on MRIs. Who knows what MRIs are? Magnetic resonance imaging. Now, I'm sure you've been told that too much radiology, too much radiation can harm you. And that's true. It can. But that's the beauty of MRIs, because magnetic resonance imaging doesn't use any radiation. It uses a magnet. Let me show you how it works. One of the first research assessments I did was over Watson's IBM. Does anyone know what that is? Yeah, so IBM designed an artificially intelligent computer that they named Watson, after Sherlock Watson, right? And its initial goal was to beat humans in Jeopardy! Sounds kind of trivial, right? But let me explain. A computer that's capable of the reasoning with input and outputting a response that is more efficient and more accurate than humans is capable of a lot more. And so once Watson reached its goal in 2011, IBM decided to take it on a different path, a path towards medicine. And so now what they're doing is they're training it for oncology, to recognize tumors in medical scans. And this intrigued me because I didn't know that it was possible to be diagnosed by a computer. And so the second research assessment I did was on an algorithm developed by the Indian Institute of Technology to diagnose multiple sclerosis. It was originally designed for glioma, but ended up working better for MS instead. A little strange, right? So I kind of branched out into different paths in radiology and neuroradiology, thinking maybe this whole computer thing isn't really going to work. But I kept coming back to it. Now, there would be a lot of benefits to this. Diagnostic imaging is expensive, and taking the time to be diagnosed from a radiologist is even more expensive, so having something that's efficient and quick would lower healthcare costs a lot. The algorithm could potentially be more accurate, and another thing is computers don't suffer from sore eyes, fatigue. Doctors do, no matter how well they're trained. Now, on the other hand, if the production of the image wasn't perfect, would the computer overlook that? Or would it notice and turn it over to a doctor? And in that same sense, human bodies differ. If there's an out-of-the-ordinary body type, can a computer diagnose that scan the same way? And the likelihood of having a program for every single disease, even the rare ones, is kind of unlikely. Now, these algorithms right now wouldn't be functioning as a radiologist in and of itself. It would be functioning either as a second opinion to a doctor or as an initial screening to find little abnormalities and turn them over to radiologists. But I wanted to know more about where it was being used right now and where people in the field saw it going. So in each of my research interviews, I asked what the opinion was on this. The first person I interviewed, Dr. Anupam Singhal, said he had no idea, but there are anomalies, and the chance of a computer catching all of those is very unlikely. The second woman I interviewed was a biostatistician, Amanda Mija, and she said she didn't know much about it, but from what she was doing with statistics right now, it sounded kind of plausible. Dr. Joseph Phillips said it's definitely possible, but it's not being used yet and probably won't be for a couple more years. Now, my fourth interview was different. I interviewed Dr. Arthi Sankaran, who was not a neuroradiologist. She was a general radiologist. And what she told me is, it's not being used in a lot of things. But artificial intelligence is already being used in mammograms. Not as the radiologist, but as the initial screening to point out abnormalities to doctors. My fifth interview was with a biomedical imaging researcher, professor at UT Dallas and at UT Southwestern. I actually ended up mentoring under his assistant, and what he told me is that he doesn't know that it's being used yet, but if he were a radiologist, he'd be incredibly scared for his job, because that sounds like a great idea. I wanted to find out the general consensus of the public on comfort with computer-aided diagnostics. So I did. For my original work, I produced a survey asking a variety of questions regarding demographics, knowledge of, and feelings towards artificial intelligence in general level of trust in a radiologist, and hypothetical level of trust in a diagnosis produced all or in part by a computer. I also asked about awareness of current use and expectations for future use of artificial intelligence and computer-aided diagnostics. For the diagnostics, considerations included various symptoms, including ankle injury, coughing and chest pains, headaches, abdominal pain, and memory loss. I was trying to understand how trusting the general public was of artificial intelligence and of computer-aided diagnostics, as well as whether they were even aware of the possibility, and how age, gender, and geographic region affected this. Here are my results. So I actually met my mentor by accident. I was going in for an interview with Dr. Alon Sherry, who's the head of the biomedical imaging track at UT Southwestern. And on my way into the interview, his secretary introduced me to Dr. Andre Martins, who happened to be walking by. Dr. Martins is one of the research associates at UT Dallas. So about a week after my interview with Dr. Sherry, I contacted Dr. Martins on LinkedIn to inquire to see if I could perhaps interview him as well. And I did, and now he is my mentor. So what Dr. Martins does for the most part is he looks at various molecules that you can put into the body that function as multimodal imaging agents, which means that they attach to atoms in the body, and they increase the contrast on magnetic resonance imaging. So this ties into my final product in that what we did is he'd been looking at various molecules for years that function off gadolinium, which acts as the ligand to attach to a certain molecule in the body and increase the contrast on a magnetic resonance. Now, out of all of the things that I learned from him, what was most interesting is the ones that attach to zinc. And zinc is present in a lot of different ways in the body. One of those being it is present in the pancreas when insulin is being released. And so being able to perhaps image the movement of zinc would be incredibly valuable, because it would not only show the actual functions of the pancreas, but it also would show different functions of the body, from protein synthesis to intracellular communications to neurotransmission. And so being able to see zinc in the body would not only increase the efficiency of research going on about pathophysiology, but also increase accuracy in diagnoses. So for my final product, I spent a few hours in the lab with Dr. Martins doing an experiment on one of the molecules that has been developed. Not in vivo, in vitro, because you have to test that first before you start injecting animals with things, to see how easily imaged this molecule was.